So before you go ahead and try this question, make sure you watch the previous video, which talks about what a particle accelerator is, so you can picture what's going on in this particular case. What's going on is we see that we're taking an electron and we're accelerating in an electric field. And what's going to happen is it's going to be moving along to the right when it's in an electric field, and then the particle is going to hit the magnetic field. And what it's going to want to do is it's going to want to curve around. So the first part of this question is asking us to calculate the initial speed of the electron entering the magnetic field. So we know we're putting in energy into the particle, and as a result, we're getting kinetic energy. So with the information we've been given, we know that it's have a potential voltage of 46 volts. Now we're working with an electron, so we can use Google to figure out the charge of an electron to be 1.6 times 10 to the negative 19 C, and we can figure out the mass of the electron, which is going to be 9.1 times 10 to the negative 31 kilograms. We know we have this new value here, 0.2 T, and this is represented by B. This is going to be our magnetic field strength. Now that part isn't important right now, but the other three pieces are, and they can fit into this equation. So we look at our equation page, we know that the change in electrical energy is Q delta V, which is equal to 1/2 mv squared. We're looking for speed, so we can rearrange this. So this becomes 2Q delta V over m square rooted is equal to V. So when I go ahead and I plug my numbers in, so 1.6 times 10 to the negative 19, 46, and 9.1 times 10 to the negative 31, you get 4 times 10 to the 6 meters per second. So now we get to the second part of our question, which is asking for the magnitude and direction of the magnetic force on the electron. So in this particular case, we're going to use our new equation we've just learned, which is Fm is equal to QVB sine of the angle. So let's work out. We don't know the angle right now, but we can read the question and figure it out. We can see that the movement is to the right, and so that would be the movement of the particle, and we know the magnetic field is directed into the page. So when we work that out, that's really going to be a 90-degree angle. That'll be important in just a moment when we're trying to figure out the direction of our force. Otherwise, we have all the information we need for this equation, so we can just plug in 1.6 times 10 to the negative 19. Speed is 4 times 10 to the 6. B is 0.2. And then sine 90. And when I plug all this into my calculator, I end up with 1.3 times 10 to the negative 13 newtons. Now, yet again, we need to have a direction because force is a vector. So how would we figure this out? Well, yet again, we know this is an electron, so we're going to use our left-hand rule, not our right-hand rule. So what we're going to be doing is we know the particle is moving to the right, so we should be looking at our hand with our thumb pointing to the right. Now our fingers point directly into the page. So if you're looking at this, what I want you to do is point your hand straight into the screen. So your thumb is to the right, fingers are going into the screen. Look at your palm. Your palm is facing straight down, so therefore the direction is going to be down. Now for our third part, they're asking us to find the radius of the electron's circular path. Remember, if you're moving right, let's just picture this for a moment. We're initially moving right, and our force is acting this way. Which way are we going to go? We're going to want to go this way. This is the beginning of what we're describing as circular motion. So we know the force from the magnetic field is going to result in force due to circular motion. Now, this is yet again going to be MAC. And we've learned a bunch of formulas this year for AC, but I think the one that's most appropriate in this case is going to be V squared over R. Now we know in this case the number for magnetic force, we just figured it out, it's 1.3 times 10 to the negative 13. And we're looking for radius, so let's do some rearranging right now. So let's bring the r to the other side and this number down. So I end up with r is equal to mv squared over 1.3 times 10 to the negative 13. So when I plug this in, so 9.1 times 10 to the negative 31 times 4 times 10 to the 6 squared over 1.3 times 10 to the negative 13, I get 1.12 times 10 to the negative 4 meters.